Hey, I'm David. Hopefully you can hear me okay. Good. I am at McGill and Mila in Montreal, and my group works on innovations in machine learning for tackling the twin climate and biodiversity crises. So we work on many different problems across a lot of different areas. You can see the group looks very big. We have a mixture of students, postdocs, interns, and software engineers, and the mixture of different folks with different kinds of um, roles within the group, in particular software engineers, really essential to making sure that our work is absolutely being used on the ground in lots of different contexts. So we focus on research that's really tailored to particular downstream applications. In the biodiversity context, next slide, please. We work on a range of different applications, can touch on three. We have several projects in insect monitoring and species discovery. So there are about 10 million species of insects estimated to occur on Earth. Of those, only 1 million have been described, and we don't have data on even those 1 million. There's a lot of information gathering that's needed for insect biodiversity, as well as just working out what's out there that we don't even have a record of. So we're working on both of those things with automated sensor systems that can track, identify specific species of insects, and also now algorithms that can suggest new species that haven't been described. We're also working on species distribution modeling, occurrence patterns, occupancy models, etc., trying to understand where species are to fill in the gaps in our knowledge of biodiversity. Biodiversity data is really extensive, but it's extremely imbalanced. For most places, we have no idea what's there, or we have an idea maybe of really common species, but we don't have an idea of the taxa that people don't care about as much, like insects, like pretty much everything except birds, honestly. So you can predict, it turns out, various kinds of ecosystem or species distribution properties from either other species or from environmental factors. Integrating with existing techniques in ecology, we're looking to leverage machine learning to scale this up. And then as an example of some of our work closer to remote sensing, we work in multimodal forest monitoring, so trying to integrate lots of different tasks across tree species identification, tree crown segmentation, carbon stock estimation, and many other different things with data from aerial, satellite, drone, various kinds of imagery. The unifying theme across all of these is typically we work at problems at the intersection of some sensory modality, often computer vision, but like some hardcore machine learning challenge. So we're not as computer vision specifically, we're working on a machine learning challenge that is adjacent to some sensory modality like computer vision. We also work on a bunch of other things in climate change. We work on accelerated climate models. We work on materials discovery and various other applications. Final slide. In terms of logistics, we're in Montreal. The application process is to McGill if you're applying for a master's or PhD position. You apply to McGill, and then you automatically get an affiliation at Mila. Also, we have other affiliations like the ABC Global Climate Center. If you're interested in a postdoc, I think that's probably not for the majority of this audience, reach out by email. We also have intern positions. So if you're a grad student somewhere else, you can reach out for an internship. We do have listings on that. If you are interested in sort of more generally the ecosystem in AI and climate, you can check out further resources at climatechange.ai, which is a nonprofit that I co-lead. Thanks very much.